Welcome to Session 5 of Unit 1 in learning the course Design and Analysis of Algorithms. In our previous sessions, we seen what is algorithm, how to represent it, what about the performance analysis, and how betterly the performance analysis can be represented by using asymptotic notations. All these things that we seen in our previous sessions. Now, in this session, we are going to know about randomized algorithms. The main objectives of this session are to know what is randomized algorithm, to learn different types of randomized algorithms. The learning outcomes of this session are, by listening this session, one can understand what are randomized algorithms and able to write randomized algorithms for various applications. Let us see this video. By seeing this video, you can understand where we are using the random numbers and the randomized algorithms in our software applications and in our day-to-day life. What do you understand from that video? From that video, you can observe that we are using the randomized algorithms in our cryptographic techniques. We are using the randomized algorithms in game designings and in various applications in developing the apps, in mobile apps, in developing the web pages, in developing some software applications. Everywhere we are using randomized algorithms. So, please follow this session to learn about randomized algorithms. The topics that we are going to explain in this session are what is randomized algorithm, types of randomized algorithms, example algorithms, and applications of randomized algorithms. Coming to what is randomized algorithm. What is randomized algorithm? The randomized algorithms can also be called as probabilistic algorithms. Randomized algorithms are also called as probabilistic algorithms. Now, how to define randomized algorithm? An algorithm that uses random numbers to decide what to do next anywhere in its logic is called as a randomized algorithm. Here, in its logic, in the algorithm's logic, anywhere, what to do next? Here, from this step to next step, what to do next? To decide that it uses random numbers. What is randomized algorithm? An algorithm that uses random numbers to decide what to do next anywhere in its logic is called as a randomized algorithm. For example, simply saying quicksort. In quicksort, we select a pivot element to partition the given array. That pivot element can be selected randomly. And advantages of randomized algorithms. The randomized algorithms are very simple and easy to understand. Their length of code is also very simple. Simple algorithm we can write, and these are very easy to implement. As well as these algorithms are very fast and having a very high probability of getting optimal output. The algorithms are very simple and easy to implement. Their length of code is simple, and also these are fast algorithms, and these are having a high probability of optimal output. Now coming to types of randomized algorithms, let us see, before going to see the types of randomized algorithms, let us see, just I given a indication of randomized algorithm. Here you have an algorithm. This algorithm, here you have an algorithm. This algorithm takes some input. After processing that input, it produces output. While it is in processing the input, at anywhere in its logic, it uses some random numbers to process that input. So finally, it produces some output. Always this gives the optimal output. So see the types of randomized algorithms. We have mainly two types of randomized algorithms are there. One are Las Vegas algorithms and two are Monte Carlo algorithms. We have two types of randomized algorithms, Las Vegas algorithms and Monte Carlo algorithms. What are Las Vegas algorithms? What are Monte Carlo algorithms? Let us see. Las Vegas algorithm is a randomized algorithm that always outputs a correct result, but the time in which it does so is a random variable. Do you understand what is Las Vegas algorithm? Las Vegas algorithm is a randomized algorithm that always outputs a correct result. Always it gives a correct result. But by which time it gives that correct result? We cannot predict that time. By which time it executed, its execution is completed. What becomes the time complexity of that Las Vegas algorithm? We cannot predict the time complexity of that Las Vegas algorithm. It becomes a random variable. For example, randomized quicksort. Randomized quicksort is a better example for Las Vegas algorithm. And Monte Carlo algorithms. What is a Monte Carlo algorithm? Monte Carlo algorithm is a randomized algorithm with deterministic runtime but some probability of outputting the incorrect result. Here, do you understand what is Monte Carlo algorithm? It is a randomized algorithm which is having some probability of incorrect output, but its execution time can be predicted. It is having a deterministic runtime. Okay, we can predict the execution time, by which time it completes this its execution. We can predict that time. So, the example for that Monte Carlo algorithms is randomized algorithm for approximate median. Now here, what is Las Vegas algorithm and what is Monte Carlo algorithm? Las Vegas algorithm always gives a correct output, but its time complexity cannot be predicted. Monte Carlo algorithm is having some probability of incorrect output, but its time complexity can be predicted. It is having a deterministic time. Right. I am going to explain this Las Vegas algorithm and Monte Carlo algorithm with a small example. Let us see first Las Vegas algorithm. Here I given an algorithm, Las Vegas algorithm, a randomized algorithm. See the algorithm steps first. A is equal to 5, 7, 2, 1, 3, 4. Here A is an array which contains 6 elements. Here I am going to repeat some steps. What the steps that I am repeating are k is equal to rand int of n. If a of k is equal to 1, then return k. Here what I am doing? Here I am repeating these steps. I am repeating these steps. What are those steps? K is equal to rand int of n if a of k is equal to 1. That is, k is equal to a random integer is generated. Here, k is a randomly generated value. So here, if k is generated as 3, let us observe. K is generated as 3. Now here the index values of these are 4, 5. Now here if a of k is equal to 1, that is a of 3 is equal to 1. Yes, a of 3 is 1. So it returns k, that is nothing but 3. the index of that particular element. So even in the first attempt, the 3 may not be generated. Random integer 3 may not be generated. But it has to generate within the n, the random integers within the n. So in the first case, it may generate 5. In that case, the k cannot be returned. In the second case, it may return 4. In the third case, it may return 2. In the fourth case, it may return 1. In the fifth case, it may return 0. In the sixth case, it may return 3. So at some place, it returns a value 3 and it finds the element a of k is equal to 1. So that's why always it gives a correct result. But by which time it gives that correct result? By the first step or by the second step or by the third step? We cannot predict that time. So that's why this Las Vegas algorithm always gives a correct output, but its time complexity cannot be predictable. Indeterministic time complexity. It is having an indeterministic time complexity. Right. Let us see the next one, Monte Carlo algorithm. The example for Monte Carlo algorithm is find Monte Carlo algorithm of x, n, k. Here x is an array which contains n elements and k is the key element which is to be found. The presence of that k should be found in the given array x. Now let us see. I is equal to 1. Repeat, randomly select one element out of n elements. I is equal to I plus 1 until I is equal to k or a is found. Let us observe this algorithm. We are selecting randomly one element from the given n elements. Here your array contains n elements. Out of those n elements, I am selecting one element. Now, after selecting that element, I am incrementing I value. Suppose for example, I selected an element 5. I selected an element 5 from the given array x. Now, that 5 is not equal to a. That 5 is not equal to a. And let us take k value is 2. K value is 2. Now here, by the execution of this step, I becomes 2. In this case, I value is equal to k. The process ends, but we did not found a in the given array. So it is having some probability of incorrect result. But in sometimes, suppose for example, a value is 6, the randomly selected value is 6. Then it is equal to a. In this case, I found a, the algorithm is terminated. So in this case, I have a correct result, correct output. But in some cases, it may terminated with incorrect output. So Monte Carlo algorithms are having some probability of incorrect output. But I can predict its time complexity. When suppose for example, if k is equal to 2, within one step, the algorithm is terminated. If k is equal to 3, within 2 steps, the algorithm is terminated. Since I value is incremented as 2 for the second step and I value is incremented as 3 for the third step, in that case 3 becomes 3. So the algorithm is terminated. So we can predict when algorithm terminates, what is the running time of algorithm. So that's why in case of Monte Carlo algorithms, there is some probability of incorrect output, but its running time is deterministic. I hope you all understood both Las Vegas algorithms and Monte Carlo algorithms. Let us see the applications of randomized algorithms. Randomized algorithms are having a huge applications in cryptography as well as in cloud computing for load balancing various servers, and also we have its applications in number theoretic applications, and we are using those randomized algorithms in data structures, and we are using those randomized algorithms in algebraic identities, and also we are using them in our graph algorithms such as minimum cost spanning trees, all pair shortest path, traveling salesperson, etc. And we are using the randomized algorithms in counting and enumeration. Also we are using in the distributed computing to avoid deadlocks, etc. And we are also using the randomized algorithms in mathematical programming. So all these are various applications where we are using randomized algorithms. So here I hope you all understood the concept randomized algorithms. Now I am going to summarize the concepts what we explained in this session. In this session we explained about what is randomized algorithm, what are the different types of randomized algorithms. We have two types of randomized algorithms, Las Vegas algorithms and Monte Carlo algorithms. I explained the two types of algorithms by taking examples, and also we discussed about the applications of randomized algorithms. To assess yourself, I given some questions. Let us see these questions and answer these questions. The first question is randomized algorithms uses option A, integer numbers, option B, real values, and option C, random numbers, and option D, none of the above. The next question is, which of the following statement is wrong related to randomized algorithms? Option A, Las Vegas algorithms always output a correct result. Option B, Monte Carlo algorithms are having some probability of outputting the incorrect result. Option C, both algorithms can be executed in a deterministic runtime. Option D, none of the above. The next question is, write a short note on randomized algorithms and explain the types of randomized algorithms with examples. So prepare answers for all these questions and share the answers through the given mail. In this presentation, I used the digital content from various public sources. So this presentation is used only for educational purposes, not for any commercial purposes. Thank you for listening the session.